Hi, everyone. Welcome. Just going to give everyone a minute to enter the room. Right. It's also really nice to see people with their cameras on. It's nice to have a sense of community here. And it's really nice to see everyone around. Right. So welcome to a technical workshop with Guillermo from Evmos, who's going to be talking to you about building on Evmos and about accounts. So I am going to hand it straight over. There's going to be room for questions at the end. So please do feel free to put them in the chat or message them to me, and I'll keep an eye on that. And yeah, over to you, Guillermo.
Okay, thank you. So yeah, we start to this workshop with the type of transactions that the Evmos network supports. So I don't know the background for any of you, but usually you have Ethereum-like networks where they support Solidity contracts, and then you have another type of networks where they have their own transactions. So Evmos is in the middle, where you can send any Ethereum-like transaction and it's going to work. And then you have your Cosmos transaction, where is the way that you have to interact with the proof of stake of any Cosmos chain. So for this workshop, we are going to be centered around the Cosmos transactions, because Ethereum transactions, you can look for any tutorial on internet. There are like 1 million tutorials on how to make a Solidity contract, how to deploy it. Everything is the same as Ethereum. You just need to point to the Evmos network and it's going to work. So for this workshop, we are going to be working with Cosmos transactions. And I make a quick list of what a normal user will need for this, or will use on the Cosmos side of the chain. And yeah, the quick list is the user is probably going to want to transfer their coins from one wallet to another inside the chain. So if I want to move my Evmos to another wallet, I'm going to send a transaction that is a message send. If I want to transfer my coins to an exchange, I'm going to use the transfer. Transfer is IBC transfer. That is kind of a bridge that is really secure, and it connects all the Cosmos networks. So it's the same as message send, but it works across several Cosmos networks. And then we have the proof of stake stuff, where you can delegate your coins and it will freeze that coins and will yield you more coins as a reward for having them staked. Then you can withdraw your rewards, and then you can vote on governance in case you are interested in one or another proposal. So that's like a quick overview on the transactions, on the type of transactions. Then we are going to start working with the Cosmos transactions. So I may go a little bit fast because this is just introduction. Then when we go into the code, it's going to make sense, everything that I'm saying. But yeah, we are only going to work with message send because it's really easy. And if we can make the message send work, create any other transaction is just replacing the create transaction call, and everything else that we are going to implement is going to work fine with our implementation. So message send, we are going to have the sender wallet. It's the wallet that is going to send the coins. We are going to have a receiver wallet, that is the wallet, destination wallet. We are going to send an amount of coins and then the type of coin that we are going to send. Cosmos coins has a lot of denomination that can be created in the chain. So it's not like Ethereum that you only have the Ether. For Cosmos, you have coin denominations that you can think about it as ERC20s that are native to the chain. So you can have Evmos, and then you can have like Osmos inside your Evmos chain. So you need to define the coin denomination. It's just another step different from Ethereum or Bitcoin, where you just are using one coin denomination. Okay. So here we start with the tricky part, how to create a Cosmos transaction. We need to define what kind of transaction do we want, and in this case it's message send, but then we need some values that can be obtained via the blockchain. for our wallet. So we are going to need our wallet address, our public key, the account number, and sequence. So wallet address is your address, the same as any other chain. Your public key is a way to represent your wallet. Then you have the account number, that is the number that you are given by the blockchain when you first receive one transaction. So let's say that I go to a faucet with a new account. As soon as I click receive funds, I'm going to get the coins on the network, and the blockchain is going to assign my account one number. That one is the account number. And then we have the sequence that is the same as the nonce on Ethereum, that when it starts with 0, then I send a transaction, it's 1, then 2, then 3. That way, there is an order on all the transactions that you are sending, and you cannot override one transaction before another. So we need to get these values. So there is an endpoint where is the accounts endpoint, where you can send your Evmos address, and it's going to return something like this. Here we have the address, but the address we already know it because it's one of the params of the endpoints. Then we have the account number and sequence. The problem is with the pub key. The pub key is a value that is optional on this response. The pub key is only going to be generated when we send the transaction, because to generate the pub key, the node, so you send a transaction to the blockchain and you send your signature, and using that signature, the blockchain is able to create your pub key, or at least determine your pub key. So if we are sending our first transaction, the blockchain still doesn't know the pub key, and this value is going to be empty. So to send the first transaction, we need to create the pub key locally. And we are going to see how to create it when we are sending transactions with something like a bot, or connected with MetaMask, or with Kepler. So this seems like kind of easy, but it's usually the main blocker for people starting to develop with Evmos, because they cannot find this pub key value. So we have 3 ways to sign, at least the ways that we are going to see in this workshop. The first one is programmatic signing. So this one is when you want to create a bot, and you are going to have your private key in a server or your local machine, and you want to sign transactions without the user needing to click on sign on an extension. So for this one, we are going to use a library that I created that is called evmos.js wallet. This one already handles the public key generation. And the way that it works is we try to get the pub key information from this endpoint, but if this endpoint fails, we are going to sign a personal message called generate pub key. And then we are going to get the pub key from that signature. So this function, what it does is it reads the signature from your wallet, and then it needs the message that was signed. This message is like Ethereum personal message / generate pub key, but in U8 int array format. So that's what this function is expecting. That's why it's like this array of number, but in the end it's just Ethereum personal message generate pub key. So this one is automatically handled by the library, and you just need to call getSender. Then for MetaMask, we can do the same, but for MetaMask, we don't have access to the user's private key. So we need to go to Windows.Ethereum request and personal sign. And it's going to work exactly the same. We're going to sign a personal message called generate pub key, and then we can call the same function. That way we get the pub key when our user is using MetaMask. And the last one is Kepler integration. And Kepler integration was meant to be for Cosmos chain. So it provides you like the pub key just using the extension, and you don't need to hack your way to get it. So to finish this introduction, MetaMask is an Ethereum wallet. So to sign Evmos or Cosmos transactions, we are going to do one trick, that is AIP 712. AIP 712 is a way to sign type data. So we're actually going to represent our Cosmos or Evmos transaction as a JSON file, and we are going to ask MetaMask to sign that JSON file, and then that is going to be our signature. That's the only way that we can safely sign with, for example, a Ledger device, a hardware wallet. The only way to sign these Cosmos messages is using AIP 712. So that's a cool hack that we are using on Evmos to allow MetaMask users and Ledger users to safely sign Cosmos transactions. And Kepler is at the beginning it only supported Cosmos transaction, but the last PRs they added support for Ethereum transactions and Cosmos transactions. So yeah, that was kind of fast, but this is the introduction. And with all this information, what we are going to do is create a faucet where user can request funds to our bot. We are going to create an API for that bot. And then we're going to create a small web page where the user can connect with MetaMask or Kepler, request funds, and send funds between the two wallets. We are going to be live coding a little bit, but I don't think that we are going to have time to live code everything. So probably for the web page, I'm going to just copy and paste the code that I have ready for this workshop. But yeah, let's start with the coding. The first thing that we are going to do is to create, in a second, is going to create the faucet. So this is the bot way to sign the transaction, the programmatic way. So we're going to create our faucet. By the way, all these nodes and the code is going to be uploaded as soon as we finish this workshop. So you don't need to take notes if you don't want. Everything is going to be uploaded. So yeah, we are going to create our faucet. We are going to use TypeScript because Evmos.js is a JavaScript TypeScript library. So we're going to init our project. And then we're going to add Evmos.js. Then we're going to use the wallet, Evmos.js wallet, Express for the server, for the API, and course, so we are able to connect to that using a React app. This is going to take a little bit, but yeah, after that, we are going to install all the developer dependencies. That is, so we need to add TypeScript, types, Express, and course. Types, course. And now we can start coding. So the first thing that we are going to do is create a constants file. And this constants file is going to have our seed phrase that we need to keep really secure because anybody with this seed phrase is going to be able to send transactions using our wallet. So let me find my wallet. Yeah. You got to trust me that I'm going to put the wallet there. Okay, so we have our constants file that is just that seed phrase. And now we can start working on our API. So first, the first thing that we are going to do is import Express to create our API. Express from Express. And we can import course from course. We can create our app, const app. So yeah, Express. Now app.use course. Okay. So the first thing that we are going to do is to create our wallet using our seed phrase. So for that, we need to import wallet from Ethers project /wallet. And now we can create our wallet. So wallet from mnemonic, and we are going to use our seed phrase. Let's import that. Import seed from constant. Okay. I'm missing. Okay. So the first endpoint that we are going to do to make sure that everything is working is to create an endpoint that it will return our wallet address. So we can create second get. We are not going to use the request. We are just going to use the response to send the response back to the server. Oh, I need to get first. We need the endpoint address. Now we have the function. It's going to be, I think, let me check my notes, but yeah. Sync response. Yeah, there we go. Okay, so I need to import response from Express. Okay, so I think that this should work. Let me see if I'm not missing anything. Yeah. So we are going to send the response that is going to be. So we were talking about having two kinds of transactions. That we have the Evmos transactions and the Cosmos transactions. The same applies for the wallet. The wallet can be encoded in Ethereum format, or it can be encoded on Cosmos format. So we are going to send the ETH format as wallet.address. This one, we can call it and see the results. But for Evmos, we are going to use our first evmos.js function, that is the address converter dot ETH to Evmos. Is going to convert our wallet address to the Evmos format. So let me fix this one. Okay. I think that if I'm not missing anything. Okay, what I'm missing. Let's send. Okay, let me copy and paste from my note because I cannot type, but yeah. Okay. So then we need to start our app. We're going to make it run on the 8080 port, and then we're going to console.log server run. I'm missing this one. Okay. So we are in the faucet folder, and we're going to run the API server running. So to test it, we can make a call request to make it bigger, localhost 8080 address, and we have the ETH wallet in, so the wallet in Ethereum format, and then we have the wallet in Evmos format. So sending to any of these wallet will result in the transaction arriving to the same address. It's just a different way to encode it. This was created this way because we wanted to support all the Ethereum tooling on Evmos, but we didn't want to break anything on the Cosmos side, so we support both of the encodings. Okay, so this one is to get the address, and we are only using from Evmos.js this address converted to move from one type to another. Then we can make a balance. So let me directly copy and paste it and I'll explain it. We can create the balance endpoint. So let me fix this. We're going to import provider. we need to define the denomination that we're going to use. We're going to use Evmos, that is the mainnet denomination. And then we need the URL for where we are going to request the information to the chain. So for addresses, we don't need anything because we are running just with the values that are stored on the wallet address. But for balance, we need to actually query the chain and ask them what is the balance for our wallet. So the provider's library inside of evmos.js generates you the endpoints where you can fetch and get the values. And it also provides you something like the types for each response in case you want to be type safe. One thing to consider is that when you use any function from the provider and it requires an address, you must send the address in the Evmos format, because this one is going to query the 1317 port is like the REST API for Cosmos chains. So it's only going to work with Cosmos or Evmos encoded address. Sending an Ethereum address here is going to tell you that the wallet is incorrectly formatted. So after creating the endpoint balance by denomination, we're going to send our wallet address, we're going to send the denomination, and then we're going to fetch and get the JSON from that endpoint. And then we are going to return on the API the balance for this wallet. So we can relaunch the server. Let me see. I didn't import request. I can remove it. Okay, so if we go to balance, we have this amount of Evmos. That wallet is the one that I have. It's my MetaMask account 1, that it has 0.956 Evmos. Evmos is sharing the same amount of decimals as Ethereum, so we have 18 decimals. So that's why this number is so big. You can think about Evmos as the same as weights on Ethereum. And we are going to create our last endpoint that I'm just going to copy and paste. Yeah, we have not a lot of time. Okay. Let me explain the faucet endpoint. So to fix the imports request. I can type. Oh, I cannot type request. Okay, so let's fix all of these first. Okay, I'm just importing everything, but it's from the library that we installed at the beginning. So here we have the faucet endpoint. This faucet endpoint is going to allow us to create a message send. That was the idea behind this project, and send transaction from our wallet to any wallet that asks us for funds. So let's move this one here. Okay, so what is this doing? So we have /faucet/address, and we are going to read that address. This transaction is also an Cosmos or Evmos transaction, so we cannot send the address in the X format or the Ethereum format. So the first thing that we are going to do is that if the address starts with 0x, we are going to convert it to Evmos. And then we need to get the sender information. So if we go back to our nodes here, Cosmos transactions, we have our pub key, account number, and sequence. And we can get all these values from this getSender function. This getSender function is the one that we were seeing. Yeah. So this getSender function queries the blockchain, and if it doesn't have the pub key set in the response, it just calls this function inside. But it's a nice helper to just call it once. It's going to ask the blockchain for our account information, and we're going to have everything ready to sign the transaction. So then we need to create the transaction. For this one, we are going to send a little bit more. We need the destination address, the amount, and the nomination. The nomination is Evmos. The amount we are going to send, I think that is 0.01 Evmos. And the address is the one that we are reading from the request. And then we have this method transaction.createMessageSend. Here, all the Evmos.js is going to provide a way to create all the messages that are supported on the Evmos chain. So everything else is going to be the same for every transaction. And if you want to send any other transaction, you just need to change these two values, like the params for your message and the kind of message that you want to create. Everything else is going to be shared, like the get sender and how to sign and broadcast is the same for every transaction. So for this case, we're going to send the transaction to mainnet. This one has the mainnet ID. We are going to have the mainnet fee. The sender is the one that we got from the blockchain. This workshop faucet is a memo that you can send like a small message inside your transaction, and then you have your params. The params is the thing that are needed for the message sent. This one will create so transaction is inside Evmos.js, if I didn't say that, but yeah. After that, we can sign the transaction. We just need to send the wallet, the address, the transaction, and the chain ID. And then the transaction rest is we are going to broadcast the transaction, the signed transaction. So this signed transaction using IP and broadcast call, and also the get sender, these three things are the ones that we are going to re-implement on the front end to be able to get the sender, sign, and broadcast using MetaMask and Kepler. Right now, we are using the helpers from the Evmos-TS wallet library. So if everything works fine, we should be able to call the API. Let's see. Faucet. What we have here. Yeah. If we call faucet, it's going to take a little bit. So what happened here is we call faucet with this wallet, and we got the sender from our wallet. We created the parent for the message sent, where the destination address is the one that we just sent. We create a transaction, we sign it, we broadcast it, and then we send the result to the API. So if we copy this transaction hash, we can actually look that it was sent to mainnet. If we go to min scan, it scan Evmos, and we look for the transaction hash. We can see that the from address and the to address are our faucet wallet, and then the address was converted from the X format to the Evmos format. And here we have the memo where is workshop faucet, the fee that we pay, and it was sent 1 minute ago. So that's the way that we can create like application that will sign transaction automatically, and we don't need to worry about anything else. So the second part of this workshop is how to integrate this with a front end. But that's not really the scope of this, because the front end is just calling the API. But then we are going to create message send transactions on our front end, and we are going to allow the user to sign that with MetaMask or Kepler. So let's start making the front end. Sorry if I'm going a little bit too fast, but believe me that if you see how to integrate MetaMask and Kepler, then any application that you want to do is going to be much easier, because if you never created an application using, like connecting to Evmos, making this wallet integration is going to take you like 2 or 3 days easily. So that's why I'm going a little bit fast. Sorry about that. But I'm going to share all my notes and you can review it later. Okay, so we are going to create a Next.js application with TypeScript, and we are going to install Tailwind CSS and Evmos.js and signature to PubKey. We are going to use Tailwind CSS just to have some design there, but it's going to be really basic. I'm not really a front-end developer, but you can use whatever you are used to. For this library, we're not going to use evmos.js wallet because we don't want to have anything related to private key in our frontend. We want the users to have all their phones safe, and we just want them to sign using wallet extensions or ledgers or whatever device they have. We don't want to keep the responsibility to keep their seed phrase safe. So we are going to activate Tailwind. Well, our folders here. Oh, I didn't copy. Okay, and then we need to remove the styles and override them with the Tailwinds one. Okay. Okay, so now that we have that ready, we can start coding. So the first thing that we are going to do is to create the src folder. Then we are going to create our components folder. And here we're going to create our faucet tsx. This one is going to be the component that is going to connect with our API. I'm going to just copy and paste this code and explain you what it does. Yeah. So, okay, let me also demo the code so you can follow it easily. We're going to remove the main file and we're going to just keep the things that we want. There we go. And we are going to run this VM to run the server. So let's go to localhost. Okay, so this faucet component, it's really simple. The only thing that it's doing is asking for the, let's follow the code here. When it loads, it's going to ask the endpoint, the address endpoint for the faucet wallet address we have here on the front end. And then it's going to ask for the balance. And it's going to store it on use state values. So we are just drawing that values, faucet wallet and the balance. And that's it for the static data. So if you are in production, you probably want to automatically update the balance every time you send a transaction and things like that. But this is good enough for this example. So then we need to call the API. That the API is going to just call the localhost 8080 faucet and the user wallet. So this one is pretty standard for any API integration. So you probably know how to do it. But the things that we are going to look into is how to get the address from a MetaMask extension or a Kepler extension. So if I click on get address from MetaMask, this one is my currently selected address. That is account 1. So this one is the same as this one because I'm using the same as the wallet on MetaMask. But if I change to account 2 and I click on get address from MetaMask, it's going to change to my account 2. And then if I click on Kepler, I'm going to get my Kepler address. That is this one, 16. Yeah. So how does it work? So if we go to get Kepler address, it's pretty simple. So I declare this global because TypeScript and type safety. I think that Kepler and MetaMask, they have their own libraries with the types, so you can probably use the correct type instead of any, but for the sake of this workshop, I'm just using any. But yeah, the way that Kepler works is you enable. So I don't know if you have used Kepler before, but Kepler supports a lot of Cosmos chain. So you can go to Cosmos Hub, you can have osmosis. Every one of these chain is going to have its own address. And most of them are just the same address encoded for each of the different prefix. But for the case of Evmos that we are working with Ethereum transaction, is actually generated differently. So you cannot just convert your osmosis address to Evmos. That's not going to work. You need to create your Evmos address with the Ethereum way to create Evmos address. That is coin type 60 instead of 180. But yeah, so the first step is telling Kepler, yeah, enable Evmos mainnet. This is the chain ID for Evmos mainnet. So the first step is we enable mainnet, then we get the signer for mainnet. And then from that signer, we can get the accounts. And from that account, we get the first one and its address. So with these 4 lines of code, we can just click on get address Kepler, and it's going to get our address, and we can use this address as the param to the faucet endpoint. And then for MetaMask, it's kind of the same. For MetaMask in production, you probably want to add a little bit more of code here where you can suggest the user to connect to Evmos in case they are currently connected to Ethereum. To get the accounts, it's not a big deal because the account is going to be the same for Ethereum and Evmos, but for signing transaction, if you send the Evmos chain ID, it's going to fail if the user has currently selected another network. So yeah, there is, if you go to the Kepler documentation, it's released just 2 lines of code where you suggest the 9, so the chain ID is 9001. If you suggest that chain, is going to work fine. But yeah, to get the address, so we call the MetaMask Ethereum request account, and then we get account in position 0. So click here, we click here, and it works. The only thing that is doing, so it's returning a string, and then the only thing that we are doing with it is storing it in a variable using useState. And then when we click on the button to request coins, it's going to just read the useState value. So if we, for example, in MetaMask, we have 0.013, we can go to MetaMask, request coins, it's going to call the API, and now we have transaction sent with this hash. And if we go to our wallet, we have 0.02, so it works. And if we go to the Explorer, we can check that the transaction was actually sent 19 seconds ago, so it's fine, and it has the correct memo. For Kepler, it's the same. We can test it out. Here we have 0.001249, and if we click request coin, it's going to send the transaction. And if we look for this transaction, it should be already included in a block. 12 seconds ago. And if we go here, we have the new balance. This one wasn't there earlier. So that's the way to connect to MetaMask and Kepler to just get the address. Oh. Now, what we are going to do is to create a transaction, a message send transaction. So this one is a little bit more of code. We need to create some files. So the first one is going to be constant.ts. And this one are going to be the constants that we are going to use for Evmos. So we have the chain ID and the fee that we are going to pay for each transaction, and the endpoint where we want to broadcast the transaction when it's already signed. And we also need this endpoint to get like the sequence and account number. So here, one thing we can see is that the chain ID, we have two types of chain ID. Chain ID is the chain ID that you need to use when you are sending Ethereum transactions, and Cosmos chain ID is the one that you need to use when sending Cosmos transactions. That's why we have two instead of one. And the mainnet fee is the amount of gas that you are willing to spend, and then the amount of Evmos that you are going to pay for that amount of gas. So we have the constants. Then we are going to create a file that is going to be chain.ts. This one is going to be a helper. So let me paste it here. If we go back to our faucet code, the first step, here we are in the faucet code. So the first step was to get the sender. So we are going to create in the front end a helper like this one. So we have the first step on the front end. So here we are back on the front end. The function that we are going to create is the same, get sender, and we are going to get the address and the pub key. So this one are parameters that we are going to send. These two parameters, we are going to generate them using the wallet extensions, and the account sequence in Amber, we are going to use them from the API response. So it's going to use something like when we query for the balance, instead of querying for the balance, we're using the endpoint account and we are passing the address. This assumes, so this one is the address, it's something like Evmos1. It will break if we send the other format, like the 0x. This one is not going to work. So when we call get sender, we must convert the address to the correct format first. So the wallet information endpoint, we can query that one. If we go back to our nodes, it's the endpoint that is going to return this information. So we do the fetch, we JSON the response, and then we can get the sequence and the account number. And we have this one in a separate file because we want to use the same function for Kepler and MetaMask. So we have it in this chain.ts file. Then we need to create the metamask.ts file. And we need to do two things with the MetaMask. I'm going to copy the first one. We need to get the sender, and then we need to sign and broadcast the transaction. So let me see if it works. Yeah. So let's go back for a little bit to the faucet code. Here we're in the faucet. We have the sender. So right now we have on the front end a helper that is going to get us the account number and account sequence, but we don't know the account address and the pub key yet. So the first thing that we are going to do is to fix that. And then we are going to create another function to sign and broadcast the transaction. So this one, we are doing this way because if we have the MetaMask get sender and sign and broadcast transaction, then we can reuse this code or that code to sign any other transaction. And so the MetaMask and Kepler code is going to be the same for any application that you made. And the only thing that you are going to change is only these lines. So that's why we are doing that way. So if we go back to the front end, we are going to get the MetaMask sender. So for the MetaMask address, we already have it. It's the function that we already have, because if I click on get address MetaMask, it's giving me the correct address. So this function is the same one that we were using here, that the Ethereum request accounts. That's already implemented, so that's fine. And we need to get the pub key. So to get the pub key, we already, in the introduction, we saw that we can call this personal sign and create the pub key using a signature. So we just copy and paste this code and it's going to work. So we have the MetaMask address that is in X format. So we are going to convert it to Evmos format. and then we have the pub key. So we can call our getSender helper function. If we go to that one, it's this one that was expecting an address and a pub key, and it's going to return us the address, the pub key, the sequence, and the account number. So with this getMetamask sender function, we have the first step ready, and the only thing that we are missing is the how to sign a transaction and broadcast it to the network. So that's the second function that we are going to create here. Let's see if I copy. There we go. So to sign and broadcast with MetaMask, we are going to use the sender object that we created on the previous step. And we are going to send a transaction that is a transaction generated. If we go back to the faucet code, here we are on the faucet. The transaction generated is the result of executing this pause command. So for our case, is this one, transaction. So let's go back to MetaMask. So it's expecting the sender that we created in this step and the transaction that we created on the faucet. So I was talking about of AIP 712. This one is to sign type data. So we are going to tell window of Ethereum request. So we are going to tell MetaMask, yeah, sign with the address, and we need to convert the address back to Ethereum. This is where it gets a little bit confused because we were using Evmos, like the Evmos encoding to create the transaction, but then we need to go back to Ethereum encoding to tell MetaMask, yes, use this wallet. So we go back from Evmos to Ethereum, and we send the AIP to sign. So this one is generated by evmos.js. And then there is like code that you can just copy and paste, but the way that it works is we create an extension with the signature, we append that extension to the transaction object that were created by Evmos.js, and then we can just broadcast the transaction. So this code, you can trust me that it's going to work, but it's basically saying, yeah, you sign this body with this wallet, and this is the result, and this is the signature. And the only thing missing is to broadcast. So the broadcast is going to accept any transaction, and then you can broadcast using the endpoint. So this one is everything you need for MetaMask. And we are almost done. Believe me. So we are almost there. We are going to create the same for Kepler. For Kepler is easier. Let me show you. For Kepler, we are going to do the same. The address is the one that we were previously using here. When we click on get address, is this function. And then if we go back to the nodes for Kepler, to get the pub key, we just need to copy and paste these 3 lines. So yeah, the only difference is that right now I'm using the mainnet like constant instead of the hard-coded string, but it's the same. We have the address and the pub key, so we can call our getSender function. This one was expecting address and pub key and return the sender. And then we need sign and broadcast with Kepler. It's expecting the same, sender and transaction. And the difference here is this is sign direct. So for MetaMask, we sign with AIP 712, and for Kepler, we are signing with sign direct. So this one is type safety, so you can ignore it, but we just need to call sign direct. We need to pass the chain ID. So we are telling Kepler, yeah, we're signing an Evmos transaction. Then the account address is, yeah, use this account address, because on Kepler, if you go to the Kepler extension, you can add several accounts. So we are telling Kepler, yes, use the account that you have selected. And then we are telling, yeah, this is the information that you need to sign. The body bytes, the out info, the chain ID, and the account number. All this stuff is the things that Evmos.js takes care for you to create correctly, and you don't need to worry about it. You just need to code it once to send it correctly to Kepler and then forget about it. And then we are telling Kepler, yeah, it's Ethereum to sign with the Ethereum way to sign transaction instead of the Cosmos one, because we are on Evmos chain. After that, we create the transaction the same way as, so for AP, we were creating the extension. For sign direct, we can just append the signature. And then it's the same. We are going to create the broadcast call. So yeah, it's a lot to support both wallets, but the good thing is, as soon as you have this running, you can just call the get Kepler get sender and sign up broadcast and forget about all this kind of stuff. You just need to create your transaction, and that's what we are going to do. So let's say you are creating your application, all this chain, constant, Kepler, and MetaMask file, you are not going to touch them anymore, and you just need to create components to create your transactions. So the last thing that we need to do is create our message send component. And after that, we have everything running. So let me show you how this works. Let's see. And we need to add the new component to the index. So message send. Okay, so this is the part that you need to create for each of the transactions that you want to support for Evmos. In this example, we are going to use the message send. So we need to get the sender. We need to set the params that we want to send. For this case, is the destination wallet, the amount that we want to send, and the denomination is hard-coded because we are going to use Evmos for everything, at least for this example. So the way that I did it, you can do it the way that you think that is better, but to make an example, I created this use state with the sender, where we have the account address, account number, sequence, and pub key that at the beginning is empty. So when we click on use MetaMask, it's going to prompt us with the generate pub key message. We can sign it. And we have our sender and the sequence. So this is just debugging information. You can remove it if you want. And so let's go to that button. So that button, the only thing that it's doing is get MetaMask sender, the function that we just created, and then setting the provider as. So we are saving the sender, and then we are saving that we are going to sign with MetaMask. If we click on Kepler, it's the same, and we get the sender from Kepler. So this one is just the connection. You can have it like on your navbar or wherever you want, with whatever you are connected, and that's it. And then we need just to fill the form. We can send coins back to the faucet if we want. So the way that this is going to work, so each input is just saving the value on use state variables, have the destination, the amount. And so the good thing about the code that we just created is that if you want to sign and send any transaction, you just need this code. You create a transaction. If the transaction was successfully created, you can, if your provider is MetaMask, you sign and broadcast with MetaMask, and if not, you sign and broadcast with Kepler. That's why I was telling that you don't need to worry about MetaMask, Kepler, chains, and all that kind of stuff. You just need to create your create transaction function. And this create transaction is the same that we were using on the faucet. Here is just okay. So if we send with the wallet on the X format or Ethereum format, we're going to convert it. Then we have the destination, amount, and denomination, and we return the create message transaction. And we can change here the memo, so we can check on an Explorer that it works fine. But if you want to create an IBC transaction, the only thing that you need to change is these two functions, these two variables, and that is going to work fine. You don't need to worry about anything else. So just to demo that it is working, we're going to send a transaction with MetaMask. So this is the EIP 712 where we have like a JSON encoded like message. And this is, we're going to send it to MetaMask. This is our account number. We're going to pay this fee. This is the gas that we are going to spend. This is our wallet, that is the one paying. The memo is workshop transaction. We're going to send a message send this amount to this wallet, from this wallet to this wallet, and this is our sequence number. So we click on sign and the transaction was sent. So if we look for that transaction, it's workshop transaction sent 9 seconds ago. So it's working. That one was from MetaMask to the Faucet wallet. And then we can do the same with Kepler. We set Kepler here, and we are going to send the same. So with Kepler, if we go to data, it's from, we have the from, the to, the amount, the memo, and the fee. So it's the same. We can just approve it, and it's going to send the transaction. And if we look for that transaction in the Explorer, it's going to be there. Yeah, workshop transaction 9 seconds ago. And it pay a little bit more of fee because the way that Kepler works. But yeah, that was like a really quick way to how to integrate with everything. I didn't want to go over time, but yeah, we are there. But yeah, the things that I want that to make clear is that all this code is going to be available for everyone, that you can just copy and paste it. And the only thing that you need to worry about is to create these transactions, create message send and your params. And if you go to the, let me see, github.com evmos.js, and you go to packages, transactions. Here you have all the transactions that we are supporting. So you have auth, that is to delegate to another wallet. You can convert, you can vote, you can create vesting accounts. All these messages are already created. So the only thing that you need to worry about is just to create these param variables and create the message that you want to send. And everything else you can just copy and paste it. So yeah, I hope that someone understands something about what I was talking about. It was really quick, but
thank you so much, Guillermo. That was a very, very informative talk. Unfortunately, we have no time at the end for any questions, but I'm going to put my Calendly in the chat, and I'm here for one-on-one support through the whole hackathon. And if anyone would like to share your ideas or talk about what you're working on with me, please do feel free to book a call. And thank you again so much for this talk, Guillermo. It's going to be up on our YouTube afterwards, so feel free to rewatch it, and anything that you missed will be there. Thank you so much, everyone, for coming, and thank you, Guillermo, for the talk.
Thanks. Thank you for having me.
Thank you, everyone. Bye.